The universe is a place of wonders, but also of inevitabilities. Among the countless cosmic phenomena that captivate our imaginations, there's one event that looms large on the galactic horizon: the collision of the Milky Way with the Andromeda Galaxy. For decades, scientists have predicted this monumental encounter, but recent findings from NASA have added an astonishing layer of certainty to this impending celestial drama. The outcome is not just likely but inevitable. And it's not as far off in the distant future as you might think. NASA has issued a striking update on this cosmic inevitability. The Andromeda Galaxy, also known as Messier 31, is approximately 2.5 million light-years away and hurtling toward the Milky Way at an incredible speed of 68 miles per second. While this rate might seem slow on human scales, it's remarkably fast in the vast stretches of cosmic time. Earlier studies suggested that this galactic collision might lead to the formation of an entirely new elliptical galaxy, whimsically dubbed Milkometa. What's causing these two enormous galaxies to defy the expansion of the universe and rush toward each other? It's all about gravity, the great cosmic force that shapes galaxies, clusters, and even the universe itself. Despite the universe expanding at an accelerating rate, the mutual gravitational attraction between the Milky Way and Andromeda is pulling them together in what will ultimately be a colossal dance of destruction and rebirth. Collisions between galaxies are not rare occurrences in the universe. In fact, they were especially common between 6 and 10 billion years ago when the universe was much younger and denser. These violent mergers have played a crucial role in shaping the galaxies we observe today, including our own Milky Way. Led by astronomer Timo Salla from the University of Helsinki, recent studies using data from the Gaia and Hubble space telescopes have refined our understanding of the Milky Way-Andromeda collision. These simulations suggest that factors like the gravitational influence of nearby smaller galaxies, such as the Large and Small Magellanic Clouds and the Triangulum Galaxy, could slightly alter the specifics of the encounter. However, the ultimate outcome, a merger, remains unavoidable. The Triangulum Galaxy, a smaller spiral galaxy about 2.73 million light-years away, adds an extra layer of complexity to the story. When its gravitational influence is included in collision simulations, the likelihood of a merger increases. Conversely, the orbits of the Large and Small Magellanic Clouds could have a stabilizing effect, potentially delaying the collision by billions of years. But even these nuances don't change the ultimate trajectory. The Milky Way and Andromeda are destined to merge. The collision, expected to occur in about 4.5 billion years, will be a slow-motion event unfolding over millions of years. When the two galaxies meet, their stars will not crash into each other as one might imagine. Instead, the vast distances between stars mean that the individual components of each galaxy will pass through each other with minimal direct interaction. However, the gravitational forces at play will wreak havoc on the structure of both galaxies. The orderly spiral arms of the Milky Way and Andromeda will be torn apart, creating chaotic tidal streams of stars and gas. These disruptions will trigger bursts of star formation as interstellar gas clouds collide and compress, giving birth to new generations of stars. Our solar system, currently located in one of the Milky Way's spiral arms, might be flung to the outer reaches of the newly formed galaxy. From this vantage point, future inhabitants of Earth, if any remain, will witness an awe-inspiring cosmic spectacle, trails of stars stretching across the sky and the formation of a new galactic core. By the time this collision occurs, the Sun will have evolved into a red giant, nearing the end of its life cycle. Earth, if it still exists, will likely be uninhabitable due to the Sun's increasing heat. However, the collision itself will not significantly impact the Sun or the planets of our solar system. The vast distances between stars ensure that direct impacts are exceedingly rare. The impending Milky Way-Andromeda collision raises an intriguing question: if the universe is expanding, why are these galaxies moving closer together? The answer lies in the scale of the forces at play. On cosmic scales, the universe is expanding, and most galaxies are moving away from each other. This phenomenon is driven by dark energy, a mysterious force accelerating the expansion of the universe. However, on smaller scales, such as within galaxy clusters or between closely neighboring galaxies like the Milky Way and Andromeda, gravitational forces dominate. These local interactions can override the effects of cosmic expansion, leading to collisions and mergers. As the universe continues to expand, galaxies beyond our local group will drift farther away, eventually becoming invisible to us. Milkomeda, the elliptical galaxy formed from the Milky Way-Andromeda merger, will dominate the local universe. For future civilizations, this new galaxy will be the entirety of their observable cosmos, as all other galaxies recede beyond the reach of telescopes. While we won't be around to witness the Milky Way-Andromeda collision firsthand, astronomers are already studying similar galactic mergers elsewhere in the universe to understand what to expect. Advanced telescopes like the James Webb Space Telescope and the upcoming Extremely Large Telescope will provide unprecedented insights into the processes involved in these colossal cosmic events. The idea of traveling to the Andromeda galaxy has long been a staple of science fiction. But is it possible? According to the laws of physics, if we could build a spacecraft capable of approaching the speed of light, we could dramatically shorten the journey to Andromeda. However, such technology remains far beyond our current capabilities. The Milky Way-Andromeda collision is more than just a fascinating astronomical event. It reminds us of the dynamic nature of the universe and our place within it. By studying such phenomena, we gain a deeper understanding of the forces that shape galaxies and, ultimately, the conditions that allow life to exist. The collision between the Milky Way and Andromeda is a story of destruction and renewal, a cosmic dance that will reshape our corner of the universe. While it's billions of years away, the knowledge that such events occur underscores the grandeur and complexity of the cosmos. As we look to the skies, we're reminded of both the fragility and the resilience of our galactic home. In the vast expanse of the universe, we are witnesses to events that span billions of years and unimaginable distances. And while we may not see the collision of the Milky Way and Andromeda ourselves, the story of this cosmic encounter will continue to inspire and awe generations.